Hi everyone, and welcome to our paper, Spherical Epipolar Rectification for Deep Two-View Absolute Depth Estimation. This video will introduce you to our novel epipolar rectification method to integrate deep stereo matching to monocular sequences. The problem at hand is that small moving platforms often rely on a single camera to navigate, and they would benefit from real-time depth estimation. The goal is to obtain a dense depth map from two consecutive views of a monocular image sequence obtained from a camera in motion in a static scene. Given known camera pose, we aim to rectify the images to leverage traditional and deep stereo matching. Our paper introduces the following contributions: a differentiable spherical epipolar rectification model that makes deep stereo matching possible, training and inference on single camera image pairs, a spherical crop operator that reduces image distortion, a spherical rectified stereo matching process for two-view absolute depth estimation. About epipolar rectification distortion. Planar epipolar rectification breaks down if the epipole enters the image, with severe distortion triggered by even minor forward motion. Our proposed model minimizes distortion, and spherical crop leads to overall smallest distortion when compared to the leading cylindrical epipolar rectification method. Monocular two-view depth estimation. The usual approach for two-view depth relies on plane sweep of a target frame into a matching volume. We instead propose to rectify images and then use stereo matching, which will yield dense depth for both images. Here we present the spherical epipolar rectification. In this model, the image representation is mapped to the spherical representation, where epipolar lines are horizontal and disparity can be recovered along those horizontal epipolar lines. Our proposed rectification model is valid for all camera geometries, is differentiable and can be integrated with deep networks, allows for absolute depth computation from disparity, allows for control over rectified image size, disentangles geometry from matching in the depth estimation problem. The spherical crop operator restates the polar epipolar rectification as a mapping over cameras with smaller field of views. This allows us to limit the distortion by adequately controlling the range in polar coordinates according to each pair of patches. The example shows the rectification for many pairs of patches across two images. Our spherical stereo architecture is presented here. Simply put, spherical rectification is used to warp and unwarp the images, as well as triangulate disparity to depth when pose is known. Any stereo matching can be used, including OpenCV-HDBM, pre-trained deep networks, or during the training of a network, supervised or self-supervised. Here are the qualitative results. For our spherical stereo, using the permutation stereo formulation, we obtain results that are coherent in time and present low error with the ground truth. Again, we note that every depth map is generated using the two most recent image frames. Looking at the results against the literature, in a supervised setting, our proposed spherical stereo outperforms the literature at this task using a significantly smaller number of learnable parameters. Furthermore, the self-supervised model performs competitively with supervised approaches. Looking at multi-image coherence, we show that our method can benefit from using more frames. The most naive method of median filtering multiple depth maps show that using more frames is always beneficial, which confirms that the produced absolute depth is always coherent. You can contact me at this email or visit the paper's website at sphericalstereo.github.io. In conclusion, we introduce a novel spherical epipolar rectification model for solving absolute depth from two views of a monocular image sequence. We propose a differentiable model that can be effectively integrated with deep stereo matching at training and inference. Finally, our proposed model reduces image distortion compared to previous rectification method.